Welcome to Snacks Weekly on Data Science. This podcast is all about making data science and machine learning knowledge accessible and less intimidating. Today, we are going to talk about logistic optimization. This topic is based on a tech blog with the title Optimizing the Picking Process to Enable Faster Deliveries for Instamart, written by their data science team. You can find the blog link in this episode's description. Throughout this episode, we will dissect this topic from both business and data science angles. Now, let's dive in. On the business side, let's take a look at the problem to be solved.
What is Instamart and how does it operate?
Instamart is a quick commerce grocery delivery platform. It was launched in 2020 to offer fast access to groceries and essentials. Their service is available over 200 cities across India, and it caters to customers looking for quick delivery of a wide range of items. This includes produce, snacks, and household goods. Like Instacart or DoorDash in the United States, the Instamart operates with a network of dark stores, small but strategically located warehouses that streamlines order processing and dispatch. This rapid service model meets the growing demand for customers' convenience and aiming to deliver customer orders within 30 minutes time range.
So, what does the delivery process look like and how does their team members collaborate?
Great question. Instamart's logistic revolves around three main parties: the delivery experts, dark store operations, and pickers. Here is the breakdown. After an order is placed by their customer, it's sent to the nearest dark store, where pickers quickly locate and assemble items from shelves. They hand off completed orders to delivery experts waiting to make the final delivery. These delivery experts then navigate through traffic to ensure the order reaches the customer's doorstep. During peak times, such as morning or evening, the whole operation's efficiency is critical, as they need to ensure the order is delivered within their promised 10 to 15 minutes window. The dark store operations, on the other side, works to ensure each dark store has sufficient goods in stock that meets the expected customer's demand in the local market. To handle surges in customer demand while maintaining the fast delivery promise, Instamart prioritizes efficiencies at every step. While hiring additional staff always help with retrieving customer goods in the dark stores and ensure promised delivery time. Technology solutions like smart route planning and optimized order assignment is also critical to help the company to further reduce delays in a more scalable fashion. This is one big challenge and a key problem to be addressed by the team. Now that we understood the business problem to solve, let's shift gear and dive into the modeling side to see what could be a good solution. The team deployed a classic problem-solving process, and it involves three key steps. First, the team examined the current picker experience to understand where the delay happens. At Instamart, pickers are assigned orders on a round-robin basis, meaning they receive tasks in a fixed rotation, regardless of order specifics. While this approach is simple, it can create bottlenecks during peak times, leading to unprocessed orders and delays that affect customer satisfaction. Next, the team observed that There are specific travel overhead time for the picker to make one picking effort, so they explore a straightforward improvement, letting the pickers handle multiple orders at a time. This could reduce travel time by allowing pickers to gather items for two or more orders in a single trip. However, there is a challenge. If the orders contain entirely different items located on opposite side of the warehouse, the picker's travel time could increase. Conversely, if two orders have similar items, for example, bread and milk, then consolidating those items in one trip becomes far more efficient. With this insight, the team developed a mathematical model to minimize wait time by batching orders based on item similarity and proximity within the warehouse. Each pair of orders waiting to be fulfilled is assigned a similarity score based on those factors. And then, when the score exceeds a threshold, a batching algorithm groups them to reduce overall wait time. To validate this approach, the team ran a discrete time simulation using SymPy, a Python-based simulation library for modeling real-time processes. Results showed a notable reduction in the average time from order placement to picker assignment. This highlights a significant gain in efficiency. This simple but effective mathematical approach offered a concrete solution that addressed a real business problem. Now, we discussed both the business problem and their technical solution. Let's wrap it up. In this episode, we discussed what is Instamart, the business model, and the need for the team to continuously optimize operational efficiency. We explored how the team tackled the picker assignment issue, testing a multi-order batching solution, and applied mathematical modeling technique to enhance their operational speed. If you like the content of this episode, please subscribe to the channel. Give me a 5-star review and leave a comment. Your feedback is very appreciated, and I'll see you next week.